What if your thought could control a robotic arm, restore your ability to walk, or write a sentence? Well, all of this without lifting a finger. And this all sounds like science fiction, but it's not. Right now, companies are building devices that can literally read your thoughts, and they're already testing this in humans. This isn't about the future, but instead it's happening right now. In this video, we'll break down the science behind brain chips, who's building them, how far along they really are, and what it could all mean for the future of our minds. So stick around till the end to hear what 1984, Star Trek, Frankel, and also Harari have all in common, and what that all says about where we're heading. Hi there, I'm Vat, a neuroscientist and an author of several neuroscience studies. On this channel, I like to break down how the brain works, decode its mysteries, and how we can apply this knowledge to our lives. So if that's something you're curious about, I would just suggest to hit the subscribe button. When people think of brain chips, they always think about Neuralink, Elon Musk's company known for its bold promises about merging humanity with AI. But what if I told you that Neuralink is not the only one in the race? And actually, it's not even in the lead. For example, there's Synchron, a lesser-known company that is already conducting human trials. Instead of opening the skull, they thread their device through blood vessels, making their procedure far less invasive. Then there is Blackrock Neurotech, a pioneer in brain-computer interfaces. Their technology has been used extensively in academic research for over 30 years, including recent breakthroughs in communication and mobility restoration. Paradromics is working on high bandwidth interfaces, and it is focusing on people who have lost their ability to speak or move. And finally, there is Kernel. Though not aiming at restoring lost function, it is building non-invasive devices designed to measure and decode cognitive states in real time. Each of these companies shares a common goal, and that is to build a bridge between brain and machine. But how they approach that goal, surgically, technologically, and ethically, it is very different. And those differences actually matter. They affect how safe these devices are, how much they can do, and how far they can go. At the center of this revolution is something called the brain-computer interface, or BCI for short. Your brain creates unique patterns of electrical activity. BCIs detect these patterns through electrode arrays, chips which contain tiny sensors which can be placed on top of the surface of the brain or just beneath. These sensors record the electrical signals picked up and then send them to a computer, which decodes them into digital commands. In clinical settings, this has already allowed people with paralysis to move robotic arms, control cursors, and even compose emails, just by thinking. And to show how far this has come, Neuralink once showed a video of a monkey playing Pong using only its brain. No joystick, just thought. But BCIs aren't just limited to movement. In some cases, they've helped blind patients see again, just by directly stimulating the visual cortex, which bypass the eyes entirely. For example, in this paper, one woman who was blind for 16 years was able to recognize letters and shapes thanks to a chip implanted in her brain. And as mentioned before, different companies are optimizing for different goals. And for example, for Blackrock Neurotech, which has been used in academic research for a long time, is known for its stability and long-term performance. Paradromics, on the other hand, is geared towards developing chips to decode imagined speech in real time, which offers hope to people who can no longer speak. Synchron's vascular approach sacrifices some of its precision for a safer, more accessible implantation method, and it's earning it faster regulatory progress. And finally, there is Neuralink, which is focused primarily on scale. It is using surgical robots to implant thousands of ultra-thin electrodes with micrometer precision. All of this points to one thing: brain chips are definitely no longer a science fiction. But recording the brain is only part of the issue. Understanding it and also integrating with it is something we're still far from mastering. So how far along is this technology? Synchron seems to lead in terms of regulatory approval. They've already implanted their devices in patients with ALS, the same disease as Stephen Hawking had. And in one of their latest news, Synchron's technology allowed for an ALS patient to send messages, answer emails, and also watch TV, all by thought alone. And their method is being praised for its simplicity and safety, as Synchron's method does not require an open brain surgery. Then the next company is Blackrock Neurotech, which continues to collaborate with research institutions around the world, powering human clinical trials to help us understand better brain plasticity, control of prosthetics, and even treat neurological diseases. In my opinion, this company has made huge advancements in the field of BCIs, and I find that it is quite a pity that they do not make it to the news more often. For example, in 2012, their technology was published in Nature, where they showed that a woman paralyzed by stroke could move a robotic arm to drink from a bottle with a straw. And this wasn't an isolated incident, because in this paper, their technology was used to help Ian move his paralyzed hand. Or, for example, in this paper, where a paralyzed person who cannot speak could formulate sentences in real time. Or, for example, in this paper, whereby Blackrock technology helped blind people perceive visual form. So, yeah, pretty cool, right? Then we move on to the next company, which is Paradromics. This company is still in its preclinical stages, and therefore there are no clinical trial results that I can show you. But it has made great progress in designing chips to restore speech in locked-in patients. And then, of course, there is the most famous company of all, which is Neuralink, which is the most talked about company. However, it isn't the most controversial. In 2023, they launched their first in-human trial, and recently they released some videos of paralyzed patients using their chips, where they could play video games, communicate with others, and also engage in work. However, this company comes with its dark side. Remember the monkey example which I've mentioned earlier? Well, in 2022, reports emerged that many of the monkeys used in Neuralink's experiments had died under experiment. The company responded by saying that the deaths were unrelated to the implant itself, but the backlash was significant. It raised questions about animal welfare, rushed timelines, and whether scientific rigor was being sacrificed for media attention. There have also been delays in Neuralink's move to human trials, partly due to safety concerns flagged by regulators. The technology is advanced, but the path to approval is long. Unlike in general business, in medicine, speed comes at a huge cost. And from all of this, a question arises, and that is, how much risk are we willing to accept in pursuit of what these chips promise? The medical applications of these chips are extraordinary. They could give mobility back to people with paralysis, restore vision to those who lost it, and help people with epilepsy, depression, and also neurodegenerative diseases. This technology can completely flip the quality of life of people who need it. And the world is beautiful. But beyond therapy lies a more controversial dream, and that is enhancement. Some imagine a future where these chips do not just repair the brain, but also improve it. Sharper memory, faster learning, and also a seamless integration with artificial intelligence. This is where the ethical line starts to blur. We've seen versions of this future before, on screens in sci-fi movies. For example, the Borg in Star Trek, whereby biological species merge with machines in pursuit of perfection. They become stronger and better by outside metrics. However, they lost their individuality. Their thoughts weren't their own anymore. They were of the hive. And for example, the historian Yuval Noah Harari, in his book 21 Lessons for the 21st Century, warns of a future where we are sold the beautiful world that neural implants could bring, and instead we end up with corporations and governments having direct access to our thoughts and attention. Imagine a targeted ad inside your brain, and you cannot even blink away. In addition, this reality can increase the discrepancy between the 1%ers and the working class. Right now, in our reality, people who come from a poor or working class background have the possibilities to face their adversities and become rich. However, in this future, for the first time in human history, a particular social class could afford brain enhancements like plastic surgery today. And in this reality, humanity would be creating a poor class that it is impossible to escape. Remember, in George Orwell's 1984 novel, people lived under constant surveillance. However, their thoughts were their own. And Viktor Frankl, the man who survived the Nazi concentration camp in World War II, he wrote in his book A Man's Search for Meaning, everything can be taken from a man, but one thing, the last of human freedoms, to choose one's attitude in any given circumstance, to choose one's own way. And in a future with brain chips as a commodity, even this final refuge might be gone. So, in a dystopian reality whereby evolution is not biological but engineered, if your thoughts could be decoded, in your opinion really, who should have the right to read them? And in all honesty, now that we're here, do you think that you would have the right to choose?